Next up, Jay Turla. Jay is our in-house. He runs a team at Bugcrowd. He's our in-house hardware mind-blowing guru. He does, if you participate to a car hacking program, you're going to deal with Jay at some point. He has spoken at NullCon and has this amazing wealth of knowledge on this subject. And personally, just having experience with what he can do, I'm really excited for this. I think it's going to be a great talk. And take it away, Jay.
Hello, thanks, Michael, for introducing me. I'm so excited to talk about this topic. And let me just share my screen right now. And by the way, I'm sorry for the background noise. It's currently 6 a.m. here in the Philippines, so that's why you can hear the roosters crowing right now. My apologies for that. So, yeah.
Just a note, we can't see the screen yet as well. It just need to be, gotcha.
Sorry. Yep.
And good to go.
The rooster is amazing.
Yeah, total plus.
Yep. So my topic is automotive security bugs explained for bug hunters version 2.0. And the reason why it's 2.0 is because I've already actually presented this at NullCon, but the reason why it's 2.0 is that I've revamped the slides and also added other tools and also other information about automotive security bugs. And this presentation is actually gonna give you a perspective on how we look on bugs based on a car hacking program or a bug bash. So I'm actually using the Car Hacking Village logo as well because I got involved with the Car Hacking Village as well here in the Philippines, and also with the folks that I've met in DEF CON. Car Hacking Village is like a Disneyland for me, and also DEF CON as well. So who am I? I'm Jay Turla. That's my Twitter handle, and in RootCon they call me Jetman. And basically, I'm a security ops manager for Bugcrowd, and I handle the ASE team here in the Philippines. I'm also a RootCon goon and a CFP reviewer. I'm not the author of Turla malware. I've received this DMs in Twitter like 2013 or 2012 before, but I just tell them that no, I'm not even Russian, I'm Filipino. So, and like I said, I've also helped develop Metasploit modules or contribute to Metasploit modules. And in fact, last year I've actually pushed a module related to car hacking. And you can also see me at hacker conferences and also, any virtual conference right now since COVID. So here it goes. This is actually the first car hacking village in RootCon, and this was last year, and we actually taught the people or some attendees how to read the can. How to do can sniffing, can in the middle attacks, can floods, and how to fuzz a real hardware with simulators and instrument clusters. And also, we have an actual ECU simulator that is hardware based. And through my friends Aaron Mani and Nikhil Bogam, we were able to show the attendees how an anomaly detection system works, which is a kind of a system that allows you to detect if someone is like spoofing messages or sending malicious messages. It's really cool. So anyway, why car hacking? I mean, I think most of you have some questions about this. Basically, it's a fun community. Car Hacking Village has been giving a lot of information, tutorials about car hacking, how to use devices for sniffing the can, and also like they also have a CTF like events wherein they they reward hackers with actual Tesla cars, or even black badges as well. And because we use it every day, we want to ensure that we are actually safe from attacks. So that's why I have some you know interest in car hacking. And there are actually a lot of attack surfaces for cars. So I will discuss on that later on. And then if Bugcrowd says that my other computer is your computer, it's basically uh, my other computer is your car's computer, because it has uh, IVI, or it has Linux boxes like infotainment systems and telematics. So there's some computers on it. And then from my experience, car hacking bug bashes pay well. So I may not be an expert in car hacking really, but I have been active in car hacking bug bashes, and also met most of the car hackers in the scene because of bug bashes, and I thank Bugcrowd for that. So, like I said, cars have IoT too, or Internet of Things. So basically, that's another attack surface. So that's why we want to test on cars, or you know play on it. So this is a sample screenshot that I got from the previous bug bash that we have last year, and we actually paid like 224,000 US dollars. And so what you can see, these are the researchers who did it, the top 10, and the top one was able to earn 120 points for this bug bash. And it's really it's one of the best thing to see car hackers totally hack a car or bypass something. And if you want to like dive into car hacking, you don't know where to start, or you don't know um, you know what to use, what tools do you need to use, so what kind of like uh, things that you can actually work on with some of the devices available. So this is one of the best books that I could actually advise. So it's the Car Hacker's Handbook. It's by Craig Smith, and there's a picture of him there. That's actually me and my friend, who is also one of the organizers of the Car Hacking Village in the Philippines. We gave him a shot for his talk. So yeah, drink all the booze and hack all the things. Then basically, Craig Smith in that book, he actually also posted or written the common attack surfaces in a car. So you have the cellular, you have the Wi-Fi, you have the Bluetooth, you have the TPMS, or the tire pressure monitoring system, and then you have the keys. And then aside from the external things that you can do, you have the internal attack surfaces. So take for example the infotainment, the nav console, even the USB port. So the universal serial bus, that's also an attack surfaces. And then you have the OBD2 connector. So how do you usually find that? It's usually in the at the bottom of the steering wheel, or maybe at the side. So it depends. So there are actually pictures that you can Google where you can find OBD2. But if you can't find that, how do you know do CAN testing without having access to OBD2? So basically, maybe you could test some wires that are there externally for the car. Maybe you could rip off some of the sensors, and then just grab a multi-tester, and then check if it's traveling on 1.5 volts or 1.25, or over that. And if you see that it's traveling 1.5 volts, for example, from one of the wires that you rip off, that means that there's CAN in there. And in fact, there are many ways that you could attack from there. Maybe the brake lights, open the door externally by just ripping off. So I can't divulge much of the attacks that I was able to see in the bug bash, but I will just share some insights about it. And here's a graph. I just was able to grab this one from ArguSec. And as what you can see, you have the air. This is a more detailed attack surface of a connected vehicle. So you have the radio, the TCU, the transmission control unit. You have the ECU or the engine control unit. Then you have the vehicle-to-vehicle communication, body controller, locks, lights, etc. OBD2. Basically, these are the most common as well. So it's more detailed. Then we'll head on to the next slide. So for bug crowd, because we have been involved with creating bug bashes, not me, but bug crowd itself. I just triage issues in the bug bash. So basically, we have these common classifications. We have the P1 for infotainment if it's a PII leakage, and then we have if you could clone the key fob, so that's P1 as well. And then if you could pivot to the CAN bus with the infotainment, like you were able to execute arbitrary commands, and then pivot from there, execute some CAN messages, so that we usually reward that one as P2. And then P5 examples, we have the roll jam attacks, the replay attacks, and we have the other attacks as well for the RF hub, the infotainment, and the CAN. So if you have like CAN injection, you could DOS the ECU, for example. So that's a P4 issue. Now you might you might uh you may not be able to see that there's other P1 from CAN here, basically because we already have a VRT entry for authentication bypass, which is P1. So that's why automatically, if someone was able to use the security access control for cars, like being able to bypass the firewall for a car or an SGW, so that's automatically a P1 or an authentication bypass issue. So that's why we just didn't add another one geared for cars, because it would just sound a duplicate entry for a VRT. So it was I who, together with Dax Labrador, who is a former ASE, who actually added this one, and Paul, one of my teammates, Paul Powell. I mean, he was the one who committed this one. So now, like I said, it's not just about the CAN. There are other attack surfaces that you could try in a bug bash. So like I said, if you could bypass the authentication mechanism for security gateways or firewalls, so it's a P1. Like, you are not supposed to access um, that surface, or like you were able to send a certain frame, and then you were able to trigger the brake lights. You were able to train the brake sounds, or the alarm. I mean, the alarms of the car, not brake sounds, but alarms of the car. So that's a P1. And then if you are able to dump the bootloader for security gateways or firewalls, that's a P1 as well. And if you are able to program the ECU by bypassing the gateway, that's still a P1. And then, of course, because if it's a connected car, uh, it has some applications that you could download to sync with your car, right? So it varies. So if you have Android or iOS vulnerabilities, if you are good in mobile security, so here's the thing that you could try as well. So if you don't have much knowledge in CAD, you could also dive into the mobile vulnerabilities that is connected to your for an app that is connected to your car. So there was this issue with Nissan Leaf before. It's fixed right now. So Troy Hunt and his friend actually basically they were able to, you know, found out that you can actually control your the Nissan Leaf car with an app. And when they tried to like sniff the app, there's an endpoint wherein there is actually a certain endpoint that calls the VIN number of a car, the VIN number of their car itself. So if you are able to like figure out one of the VIN numbers of a Nissan Leaf, you could actually control another car for them. So the fix for that is not the security issue of a VIN, but that endpoint which doesn't have authentication. So basically, that's an issue related to web vulnerabilities and a mobile app, because from that mobile app they were able to discover that there's an endpoint that allows you to call any VIN numbers. So how was it able to, you know, access other cars? So because they have telematics module. And then for web vulnerabilities again, so it could be connected to the cloud, the telematics, the firmware update server. So take for example, what if the firmware update server has a SQL injection vulnerability? So basically, it's gonna become a P1 issue. It's gonna get the kind of rating that you have from the web vulnerabilities in the VRT, or the vulnerability rating taxonomy. Anyways, I hope I'm not boring you. Here are some of the insights that I've actually found on the net, and some of the demos that I've used are actually from my car itself as well. And I hope that you will try this, and I hope you don't break the car. So try this at your own risk. Basically, in a BMW 330i, so if you name your phone to like %X, 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 and then connect your phone to a BMW 330i, so it will cause the infotainment to crash. It will brick your device. And thanks to this researcher, we know about this one. So this is an issue between the Bluetooth stacks of the infotainment system. Next. And this actually from my car. So basically, if you have infotainment default creds, sometimes it's an issue, sometimes it isn't. But basically, we have a VRT for insecure transmission. So what if you could prove to the program owner that, hey, one of your infotainment system allows me to telnet, or work with FTP. So basically, you have there that you can actually prove that there is insecure transmission on an infotainment. So that's possible. It's possible that you can be rewarded for that. And if you know the root password, maybe you could pivot from there to interact with a CAN. So if you have access to the infotainment, maybe you could like pivot to the system and then interact or send canned messages to your car. I would say that that could become a P2 if you're able to do that. Like maybe trip off the brake lights, or trip off the alarms or the airbags. If you could do that, then yep. How about the P1 as well? This is from my car again. So because if you're not able to pivot, so this could become a P3. So if you're only able to execute arbitrary commands, because for example, if the system is like sandbox and you are not able to just send canned messages, so basically just being able to execute arbitrary commands on the infotainment. So that's something that is P3. So I have a video actually about this one, and here. So this is the chicken that the rooster that you keep on hearing actually. Oh wait, I think it's crashing. Sorry, not sure, but let me just. Can you guys still hear me?
Yes, we can still hear you.
Okay, I think the Apple is causing a DOS, but I know. I mean, it's the video lag, but let me try it again. Sorry for that one. Okay, it's okay now. So this is the POC. Not sure why this is happening, but
So we can link that on your Twitter and in the Discord after. And so
okay.
for anyone watching this on the recording, Ship Code will have his Twitter at the beginning or the end, and the link to this video will be in the comments on the video.
Yeah, sorry about that one. Let me just close the QuickTime player again, and then you know. I hear it's working now. So basically, I was able to insert a flash drive on the car, and then you know trigger command injection. So let's just move this forward. There you go. And this is I was able to execute namespace -a. So that's, if you can do that, that's a P3. But if you could like move further, being able to send canned messages, so it's a P2. Okay. Let's present it again. Sorry for the technical difficulties a while ago. But so like I said, ECU resets, if you are able to do that, bypass. So that's a P1 as well. And Chris Velasek and Charlie Miller has a book about advanced can injection attacks, which could help. So there's a link on that. And then I don't have a POC about this one, but I was able to see. So I can't divulge other issues that were found in the bug bag for NDA purposes. But to help you with that, there's a tool that I love that allows you to, fuzz something, or like, maybe get the seed key of the car. There's a tool that I love really. There's another one called Yat, which is yet another car hacking tool. This one is my favorite because it's just a command line. And basically, I have a VM running right now. So this is the Carrying Caribou. So these are the things that you could do. So if you run the test module of Carrying Caribou, you could actually send this diagnostic services and then also fuzz the UDS. So if we try to, run UDS discovery, so it will try to fuzz arbitration IDs. So this is just a virtual one because I'm running a UDS server. So as what you can see, it's trying to send this this arbitration ID 24A, and then this is the can frame, which is 021001, and there we got a request with 7DF 7E0, and basically you were able to send diagnostic session control to 710, which is the ID 7DF, and 7E0. And if we do a can dump, my can dump is already running. So these are the arbitration IDs that we were able to send. And we got a response from 77EA arbitration ID. So 710, 7DF, 7E0, those are the UDS that you can actually, you know, try. So there are other things that you could do. And in fact, if you try UDS minus H, there's actually things that you could, like security seed, ECU reset. So if you could do an ECU reset, then bypass the firewall. So that's a P1. So those are just, tips and tricks with this tool. I'm gonna do some demo later on, but here are the prerequisites for the demo. It's just a video actually. I have an instrument cluster with NanoCan. I would like to thank Mintinet for actually teaching me how to, how to solder this one, and also how to dev some Arduino and then hook it up to fuzz my instrument cluster. So if you want to start car hacking, like if you don't want to buy the whole ECU pack, you can actually just buy an instrument cluster. It costs like $20, $30, $40, $50. So it's car hacking on the cheap. And then if you get a NanoCan, we give it for free. If you find me in any conference, I actually give NanoCan PCBs, and then you just need to buy the parts like the Arduino Nano and the MCP2515 module. These are the tools from the right side of the pictures that I sent in the slide. So I have CanTac, I have STM32 Can Sniffer by TechMaker. So these guys are really good, the guys from TechMaker as well. And the Value Can 4 from Intrepid Control Systems. So if you have a NanoCan and you have any SLCAN devices, just like the one that I flashed on the video, so you could actually try the demo that I will be demonstrating later on or showing. Also, there's a good resource that actually it contains videos, presentations in DEF CON and other hacking conference, tools, open source libraries that you could start to learn car hacking. So I would definitely advise to read some of the links there, or buy some of the tools that you get there. So Jay Gamblin or Jerry Gamblin also created a VM machine that comes with pre-installed car hacking tools. So if you just want to have, if you have a Linux box, so you just need to clone it if you don't want to install a VM machine. And if you want to use Metasploit, you could actually use Metasploit as well to test. Craig Smith actually dev modules to test car hacking. And basically, so let me just get to my slide. So here are the automotive modules in Metasploit. And as what you can see, there's scan flood, there's scan probe, there's get vehicle information. And if we try to run can flood right now with my virtual can, because I'm using the virtual can just for demo purposes, I don't want to try this on the ECUs that I have. So let's try while I'm running the can dump. So I'll try to run this one. So, and we have some of the things that it's actually doing. So if you are able to flood the bus and you can really see that there's a DOS, you can actually do DOS. So that's something that we reward. And another old hack that we have, if you are able to write a while statement and then send can frames with zero. I mean, for example, the CAN frame is 0000 with 8 bytes, and then you have the CAN ID or the arbitration ID as 0 as well. It's possible that you could actually DOS the car as well, because it will throw a lot of fault codes. So that's one of the things, old hacks. If you're able to do that in a newer vehicle with a firewall, that's something that, you know, that is rewardable as well. So just tips and tricks.
That's very cool, Jay. So we're running up against time a bit here, unfortunately. So we might have to, if you've only got 1 or 2 slides left, we can watch those. But we might have to jump to Q&A. We've got a few questions as well.
Oh yeah, this is actually one of the fewer slides already. But basically, in the slide, I've already demoed this one. But here are the references and credits. And just one last video that I'm going to show. So here's the CAN in the middle in action. So I'm using NanoCAN and CANTAC to fuzz the cluster. So this is the NanoCAN and then the CANTAC. Then they're fuzzing the cluster. So that's one of the things that I play with as well at home. And because we're running out of time, I'm sorry for taking a lot of time. So I'm ready for a Q&A. So I should just stop the sharing, right?
Yeah, that's fine. If you want to end your screen share, we can jump into Q&A. So personally, I found that absolutely fascinating. I've got a pretty big interest in cars myself. I'm more into modifications and that sort of stuff, but the CAN bus side of things is certainly fascinating. One thing I was wondering though, do car hackers look at non-OEM equipment? So maybe alarms and entertainment systems, like you've got Android entertainment systems available aftermarket now, and is that the sort of stuff that car hackers look at also?
Yes. So basically, they also like try to figure out how to attack the infotainment system, the Android head units. So if you could also find vulnerabilities for that, that's something that's rewardable. It depends on the scope of the program, but usually it's in the scope.
Cool. So there's obviously a lot of manufacturers that are now using CAN bus. I guess they're all using it these days. But is there any major difference between the manufacturers? Some are better or worse than others, or?
That's actually a tricky question or interesting question. But
I guess it's hard to answer and without revealing too much information. But
yeah,
speaking generally, I suppose.
That's the thing. So I can't really speak based on the NDAs that we have, but there are differences. But they use some standards like the CAN, the FlexRay, and then other communication protocol that they use. CAN is one of the most common protocols, but there are other protocols that it's actually present. So
is the CAN bus protocol unique to a manufacturer, or is that based on a standard that's open and available?
Well, for UDS, there are standards for that, but it's unique. For example, for the instrument cluster of Mazda. So the arbitration ID for turning the speedometer is 202, but for PG207, for example, it's I think 56B, if I'm correct, if I'm not wrong, but something like that. So it depends actually. But in terms of UDS, like Unified Diagnostic Services, so they have the same, like getting the PID info, getting the vehicle info. So that's pretty much standard. But accessing some functionalities with other endpoints, so they have different arbitration IDs.
Okay. So there's obviously more autonomous vehicles and that sort of thing being in development now. Is the attack surface of internally on one of those vehicles much larger than a standard internal combustion, like a regular VW Golf, for example?
Mm-hmm.
I guess, again, can't talk about it too much, but in general.
Yeah, a lot. So basically, if it had basically, if it has telematics module, if it has more connections to the internet, the more attack surfaces. So V2V or vehicle to vehicle communication, more attack surfaces.
Yeah, absolutely.
Yeah.
All right, I think that wraps it up for our questions now. But I think I think there might be one or two we didn't get to. But if you could drop into the Discord after this and maybe answer some questions in there, that would be very much appreciated.
Yeah. Anyway, I would just like to give a warning. So I'm not an automotive security expert. So I just have like knowledge because of the things that I learned from bug bashes, from going to DEF CON Car Hacking Village and learning this stuff. So if I can't answer those questions all in all, I apologize. So yeah.
That's no problem at all. It's a fascinating area. It's definitely going to be an area that we need people looking into cars, looking into the cars they've got, and or maybe picking up an instrument cluster on eBay and playing around with it. So certainly find those issues. Yeah.
So for me, that's one of the best actually thing. If you want an actual hardware, it's good to start with instrument clusters, like how to figure out with how to turn off the engine lights, so something like that. Turn on the speedometer. It's one of the most basic thing that you could do. And then try some simulators as well, like for example the online, the virtual instrument cluster by Craig Smith, the UDS server, which is the one that I was running a while ago. So it's a good thing that you get a grasp of the basics of car hacking and CAN bus.